Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying trigonometry lecture 2. So today we'll be talking about right angles. So let's start with the definition. If two angles are such that their summation or difference is 0 or multiple 90, in that case they're called as allied angles. So what do we mean by that? Let's say we have two angles. Let's say the basic ones are 90 or 0, or let's say we have 60 or 30, or say we have 225 and 40. So these are the pairs of allied angles. How? 90 minus 0 or 90 plus 0. In this case, both summation or difference, we are getting 90, which is a multiple of 90. Right? So that's why this pair is an allied angle. In this case, we are getting summation of 90, although we are getting difference of 30, but since it's an or, summation or difference is 0 or a multiple of 90, in that case, this is also a pair of allied angle. In this case, 225 and 45, the summation is 270 and the difference is 180. In this case, both summation and difference are a multiple of 90. So that's why it's also a pair of an allied angle, right? So it's a very basic definition. Now let's try to find out the correlation between trigonometric ratios having allied angles as their arguments versus their usual form. So let's start with sine of 90 minus theta. For that, I'll be doing certain constructions. This is our angle theta. We're dropping certain perpendiculars on both x and y axis. So this is our y axis, this is x axis. If this is theta, then this is 90 minus theta. Let's call it as O, A, B, and C. So if we talk about triangle OAB, we have sine theta equals to BA divided by BO, right? And we have cos theta equals to OA divided by BO, right? Now, if we talk about triangle OOCB, we have sine of 90 minus theta equals to this angle is theta. So that this angle is 90 minus theta. So we have CB upon OB, right? And cos of 90 minus theta, that would be CO upon OB, right? If you look at this carefully, CB is nothing but OA, right? So we can write this as sine of 90 minus theta. That would be CB equals to OA divided by BO, right? Now OA divided by BO is nothing but cos theta. Similarly, if we look at cos of 90 minus theta, CO is nothing but AB, right? So this becomes AB upon OB, which is nothing but sine theta only. So we have got cos of 90 minus theta as sine theta. And we already know that, right? So that's why it's pretty obvious to understand this particular one, right? So we already know sine of 90 minus theta is cos theta and cos of 90 minus theta is sine theta, right? Let's move forward with the second case. Sine of 90 plus theta and cos of 90 plus theta, right? This is our theta, and we know that this is our 90 degree, right? if i draw if I take this angle as theta, in that case this entire angle would become 90 plus theta, right? So I'll be just drawing this one, and this entire angle for this particular ray, this entire angle from x-axis is 90 plus theta. Okay. Again, we'll be dropping certain perpendiculars. This is O, A, B, C, D, E, and F. Now, if we talk about triangle OAB and triangle ODE, we can see that these two are congruent. How? AAS property. We have this theta angle as common, we have this 90 degree as common, and we have this radius OB and OE as common, equal, right? So that's why with the help of AA's property, we have triangle OAB is congruent to triangle ODE. Okay. Now one thing to note over here, will not be writing like this. Triangle OBA is congruent to triangle ODE. Although technically it's correct, but writing in this particular manner makes it easier. Writing corresponding sides which are equal, OA with OD, OA with OD, OB with OE. Over here, we are not writing corresponding sides, although technically it looks correct, but it would make our life a little tougher if we are not writing in this particular manner. So have a habit of writing congruency in this particular manner, right? So this is not a suggested way. Now let's move forward with the derivation part. we have to find out sine of 90 plus theta, and we'll go by the basic definition in circular system. In circular system, sine of 90 plus theta would be projection of OE on y-axis, right? And this is the positive y-axis, so that would be DO divided by radius, that is EO. Now DO is nothing but OA with the help of congruency, and EO is nothing but BO divided by BO, right? And this actually becomes OA upon BO. This actually becomes cos of theta. So again, in case of sine of 90 plus theta, we have got cos theta. Let's look at cos of 90 plus theta. In case of cos of 90 plus theta, we have to find out the projection on x-axis. But over here, the x-axis is negative, right? So it would come with a negative sign. That would become FO divided by radius, that is EO. Now FO is same as ED. This becomes minus ED divided by EO. Now ED is same as AB. This becomes minus AB divided by EO is same as BO, right? Now AB divided by BO, what is this? This is minus sine theta, right? So we have got we have got sine of 90 plus theta as cos theta, and we have got cos of 90 plus theta as minus sine theta. So here's a little difference as compared to the previous one. In previous case, we have got cos of 90 minus theta as sine theta, but over here we have got cos of 90 plus theta as minus sine theta, although we have got sine of 90 plus theta as cos theta, right? Now let's move forward with the third case, that is 180 minus theta and theta. So how to draw 180 minus theta over here? Let's say this is theta, and if I make this as well as theta, in that case, this entire angle from here to this particular ray, that would be 180 minus theta. Why? Because we have this semicircle, and semicircle means 180 degrees. So if I subtract theta from here, so from x-axis to this particular ray, that angle would be 180 minus theta, right? And now since both these angles are theta, when I do the construction, I can safely assume that, or we can also prove that, but with the help of symmetry, I can say that both these triangles are congruent. This particular triangle and this particular triangle are congruent, right? So let's name these. This is O, A, B, C, D, and E, right? So triangle OAB is congruent to, again we are writing in the symmetric manner, OAB. So OED is congruent to triangle OED, right? Now let's try to find out sine of 180 minus theta. So sine of 180 minus theta, we'll look at this particular ray, that is OD, and projections on y-axis. Again over here, the projection is on positive y-axis. That would give us OC divided by radius, that is OD, right? Now OC is same as DE divided by OD, and DE is same as AB because of congruency, divided by OD is same as OB. So if I look at it, AB by OB, AB by OB, sorry, AB by OB, this becomes sine theta. So sine of 180 minus theta is nothing but sine theta. Now if we look at cos of 180 minus theta, so we have got projection on x-axis, but over here again it's a negative x-axis. That would give us minus OE divided by OD. Now OE is same as OA. This becomes minus OA divided by OD is same as OB, right? So this becomes minus times OA by AB, OA by OB, sorry, OA by OB. That becomes cos theta. So cos of 180 minus theta becomes minus cos theta. Okay. So these are the final results. Now let's look at case number 4, that is 180 plus theta. Now again, how to draw 180 plus theta? So let's say if this is theta, if I take angle from here to here, this is 180 degrees. If I add theta over here, so this entire angle becomes 180 plus theta, right? So this angle is also theta. Now interesting thing over here is, if this is theta and this is theta, these two actually become vertically opposite angles because these two are diameters. This one is diameter, so this one automatically becomes diameter. This particular ray from here to here automatically becomes diameter, right? Because of these two vertically opposite angles. Again, let's do the constructions. This is O, A, B, C, D, E, and F, right? Over here again, triangle ODE is congruent to triangle OAB, right? Because of same AAS property. Now we have to find out sine of 180 plus theta. For sine of 180 plus theta, we have to look at this ray and its projections. So we have to take projection of OE on y-axis, but over here we have negative y-axis. That becomes minus OF divided by OE. Now OF is same as DE, minus DE divided by OE, and DE is same as AB. So this becomes AB divided by OE. OE is same as OB, right? Now AB by OB is nothing but minus of sine theta, right? And if we talk about cos of 180 plus theta, in that case we have to take projection on x-axis. Again over here we have negative x-axis, so this becomes minus DO divided by OE, and DO is same as OA, so minus OA divided by OE is same as OB. So OA upon OB, that actually becomes minus of cos theta, right? So we have got a different result over here. In this case, both actually are coming to be negative. Sine of 180 plus theta is minus sine theta. Cos of 180 plus theta is minus cos theta. Now after case 4, we have case 5th and case 6th as well. That is 270 minus theta and 270 plus theta for 4th quadrant. But we won't be doing those derivations because we have done enough of derivations in these 4 cases. And we have got an idea on how to do these kind of derivations, how to relate allied angles with the usual angles, right? So let's directly jump into the conclusions part. That is the shortcut part. And before that, we have one assumption for that. So the assumption is theta is always going to be assumed as acute, regardless of whatever it is. For example, let's say we have sine of 120, 180 minus 120. In this case, 120 is an obtuse angle, but for applying these conclusions, for applying these shortcuts, we have to assume that this is going to be 180 minus theta, where theta is acute, right? Now, once we have understood this assumption part, let's look at these 3 other points. So for that, let's take an example of sine 180 minus theta once again. Okay. Now we have to look at this particular angle first. If this is an even multiple of 90, in that case, our trigonometric ratio is not going to change. If it's cos over here, it's going to be cos. If it's sine over here, we are going to have sine over here, right? Now considering the sign part, if it's going to be positive or negative, for that we have to look at the quadrant of this one. Now we have assumed that theta is going to be acute, and 180 minus theta in that case would be in second quadrant, and we know that with this, that for in first quadrant all trigonometric ratios are positive. In second we have just sine, in third we have tan, and in fourth we have cos. So considering theta to be acute, 180 minus theta is in second quadrant and sine is positive in second quadrant. So for that we have a positive sign over here, right? Let's take an example of cos of 180 minus theta, right? So in case of 180 minus theta, again 180 is an even multiple of 90, so our trigonometric ratio is not going to change. Now for the sine part, 180 minus theta is in second quadrant, and in second quadrant cos is negative, so we have negative sign over here. Now let's take one more example. Let's take cos of 270 minus theta. In that case, 270 is an odd multiple of 90. In that case, our trigonometric ratio would change. That would become sine theta. Now for sine, we have 270 minus theta, theta is acute, and 270 minus theta is in third quadrant, right? In third quadrant, cos is negative, so we have a negative sign over here. In case of cos 270 plus theta, our trigonometric ratio is going to change because we have 270 over here, which is an odd multiple of 90. And for considering the sine, 270 plus theta comes under fourth quadrant. In fourth quadrant it's always positive. Cos is always positive. So that is how these are the three rules we have defined, or you can say shortcuts for allied angles, for which with the help of which you can derive any sort of allied angle formula. Now there must be one doubt why we have considered it to be acute and it might give inaccurate results, right? So let's clarify that doubt as well. Let's take one example, sine of 180 minus 120. Over here, 120 is an obtuse angle, but for the sake of applying these formulas, we have to assume that this is an acute angle, right? So let's write it as 180 minus theta, where theta is 120 degrees. With the help of allied angle formulas, we'll be getting sine theta. Sine of 180 minus theta is sine theta, right? So that comes out to be sine 120 degree. Now sine 120 degree is nothing but sine of 90 plus 30. Now, if we apply once again allied angle formula over here, we'll be getting cos of 30 degree, right? Sine of 90 plus theta is cos theta. Now, over here, we can directly write it as sine 60. Now, you know that sine 60 is exactly same as cos 30, right? So, we have proved that even if you are going to consider theta as acute or theta is acute, regardless of whatever it is, it's going to give the same result, right? Now let's look at some important results. So the first set of results is sine of minus theta, cos of minus theta, tan of minus theta. Now you can write this as, or you can derive it as sine of 0 minus theta. Now this has become an allied angle concept. Okay. Now you can apply the formulas or shortcuts over here. I'll simply write down the conclusion over here. That comes out to be minus sine theta. This comes out to be cos theta, and this comes out to be minus tan theta. So you have to remember these things. Sine of minus theta is minus sine theta, cos of minus theta is cos theta, tan of minus theta is minus tan theta. Similarly, for this one, sine of 360 plus theta, that is sine theta. Why? Because we have come one full circle and again we have made one angle. So this is our from here to here. This is theta only, right? 360 plus theta, one full circle plus theta. So that is sine theta only. So similarly, cos 360 plus theta is cos theta, tan of 360 plus theta is tan theta. Now let's do one problem. Sine of minus 420 degrees cos 390 plus cos of minus 660 and multiplied by sine 330. Right? We'll go term by term. So the first term is sine of minus 420 degrees. So the first thing we can use over here is sine of minus theta is minus sine theta minus sine 420. Right? Now I can write this as minus sine 360 plus 60. Now we know that sine of 360 plus theta is sine theta only. This comes out to be minus sine 60 degrees. Now the second term is cos of 390 degrees. That is pretty simple. This becomes cos of 360 plus 60. Now this becomes cos 360 plus theta 30. Sorry, that becomes cos 30. Okay. Now the third term is cos of minus 660. Now cos of minus theta is simply cos theta. That becomes cos 660. Now I can write cos 660 as cos of 720 minus 60. Now cos of 720 minus 60, you can simply write it as cos of 360 minus 60. And we know that cos of 360 minus theta, that is in fourth quadrant. So that becomes cos of 60 degree, right? Now if we talk about the last one, cos of sine of 330 degrees. That is nothing but sine of 360 minus 30. So sine of 360 minus 30, basically this is in fourth quadrant, and in fourth quadrant we have a negative sign for sine, so that becomes minus sine 30 degrees. Okay, so now we have got all these values, favorable values. You can just simply calculate the answer. Now let's look at this example. Find the value of cos square pi by 16 plus cos square 3 pi by 16 plus cos square 5 pi by 16 plus cos square 7 pi by 16. Now, if you're an absolute beginner, there should be two things that should come to your mind when you see these kind of problems. The first thing is symmetry. So if we talk about symmetry, we can see that pi by 16 plus 7 pi by 16 is pi by 2. And 3 pi by 16 plus 5 pi by 16 is also pi by 2. So this is the kind of symmetry we should be observing in such kind of problems. The second thing, the second thought that should come to your mind is, after looking at cos square, we should feel the need of sine square, right? Because sine square plus cos square is 1. To make our things simpler, Whenever we are going to witness cos square, we should be first thinking of sine square. Although it might not be pretty necessary for every question to have sine square plus cos square, but just in case, the first thought you should be having in your mind is about sine square, right? That would make your things very simple. So combining both these triggered thoughts, we should be proceeding our question. Now we have symmetry between pi by 16, 7 pi by 16, 3 pi by 16, 5 pi by 16. So let's club these things together. So we have cos square pi by 16 plus cos square 7 pi by 16 plus cos square 3 pi by 16 plus cos square 5 pi by 16. Now when we have clubbed these terms together, we are going to use our second triggered thought about sine square, right? So to convert this into sine square, what we should be doing, we should be using the allied angle concept. We can write this as pi by 2 minus pi by 16. And similarly, we can write this term as cos square pi by 2 minus 3 pi by 16. So this becomes sine square pi by 16, and this becomes sine square 3 pi by 16. So if we club both these together, that gives us 1. And if we club both these together, we get 1. So 2 is the correct answer. So today's class was still here only, and we dealt with the very basic concepts of allied angles and certain problems around that. From next lecture onwards, we'll be dealing a little more tougher concepts like compound angles, some multiple angles, and transformation formulas, all these things. So from next lecture onwards, things are going to be a little more tougher, and we'll be solving a little more number of problems as compared to previous year. Right. So let's meet in the next lecture. Thanks for watching.